Welcome to this class. Today I am continuing the chapter Electricity of the subject Science and Technology of class 9. This is unit number 11 and we are today doing this part 5. The electricity chapter is divided into 6 different parts and this is part 5, and in this part we are going to focus on series and parallel combination of resistor. Look at this. Series and parallel combination of resistor. We are talking about the resistor. That's why I want to start with resistance and resistor. Then we'll be able to understand how do we connect them in series and parallel. Okay. Now, electrical resistance, what it is? The obstruction offered against the flow of current by a conductor is called electrical resistance. It is measured in ohm. SI unit of resistance is ohm. What it means? Obstruction against the flow of current. There are different metals. Each of the metal have different resistance, because when current is made to flow through aluminium and copper and silver, it passes very easily. The obstruction is very less in case of aluminium, silver, copper. And that's why they can be used to conduct electricity from one place to another place. But silver is expensive. We do not use silver. But aluminium is used to conduct electricity from power point, I mean to say power station, to our houses. And inside the house we are using copper because it has very less resistance. Its ductility is very high, and so copper is used in the home. And aluminium is used outside the home from electric station to the home. Okay, the resistance of some substances are very less, like copper, silver, and this aluminium. But the resistance of iron is more than these three, and resistance of some other metals are very high. Just for example, tungsten has very high resistance. And that's why when current is made to flow through tungsten, it becomes white hot. Different metals have different resistance. It depends upon number of free electrons. That can be understood this way also. Look at this is a conductor. And flow of current in a conductor means flow of electrons. And electron flows in such a way that it has to collide with the atom and it has to move from one atom to another atom till another end. In this process, if number of collision is more, then the obstruction is said to be high. If number of collision is less, then obstruction is said to be less. Okay, this is electrical resistance. Some substances have high resistance, some substances have less resistance. Now, let's go to another term, resistor. What it means? Resistor. The substances having high resistance is called resistor. That's why I can define this way. Resistor is an element of the circuit that is designed to produce certain resistance in the circuit. It has high resistance. If nichrome wire is used in the circuit, then we are using this nichrome wire to convert electrical energy into heat energy because its resistance is high. It obstructs the flow of current a lot. Its atom begin to vibrate more rapidly and becomes red hot. That's why this is the resistor which is designed to produce high resistance in the circuit to convert electrical energy into heat energy. In the same way, somewhere in the circuit we can use tungsten wire. When current passes through tungsten wire, the tungsten offers high resistance. That's why its atom begin to vibrate more rapidly. It becomes white hot. And these are called resistors, the substances which are used in the circuit as an element of the circuit to produce certain resistance, means to convert electrical energy into heat energy, light energy, and other mechanical energy. These elements are called resistor. And actually the appliances which we use at home, all of them have certain resistor wire inside them. That's why they are a kind of resistor. Okay. Now this resistor is represented by this symbol in the electric circuit. This is the symbol for resistor in the electric circuit. If this symbol is seen in electric circuit, then you have to understand this is the resistor which has high resistance. Okay, after this resistance and resistor, now I want to tell you about the combination of resistor. I told you a little in the previous class also. Now we are going to recall a little from the previous class and we'll compare different types of combination of resistor. Combination of resistor is basically of two types. One is series combination of resistor, another is parallel combination of resistor. What is it? If appliances are connected to each other, then we can say that resistors are connected to each other. And the appliances may be connected in series or appliances may be connected in parallel also. Okay, what is series combination of resistor? How can we define this? When resistors are connected end to end with each other and the open end of the first and last resistor is connected to the source of electricity, then the combination of resistor is called series combination of resistor. Looking at this definition, we cannot understand very easily. That's why I want to show this with the help of animated figure. Look at this animated diagram. This is a resistor. When it's one of the end, this end is connected to another, then again is one end is connected to another resistor, then they are connected end to end with each other. Now open end of first resistor and the open end of last resistor are if connected to a battery, then current flows from positive terminal to negative terminal and it flows through each of the resistor. This is series combination of resistor. When resistors are connected end to end with each other and the first end of the first resistor and last end of the last resistor is if connected to a source of electricity, then this combination is called series combination of resistor. I want to show this combination in diagram also on the board, and I want to tell you the characteristic of series combination of resistor. I mean to say, what happens when resistors are connected in series? What will be its effect on current? What will be its effect on voltage? I mean to say PD, potential difference. What will be its effect on resistance? One by one I'll tell you. Look at the board. This is battery, the symbol for battery, and two terminals of this battery is connected to the resistor. This is the series combination of resistors. This is positive terminal, negative terminal, and current flows from positive to negative terminal. This is conventional current. Now let's talk about the resistor. According to the length, thickness and different material, resistance of this resistor is different. Let's say resistance of first is R1, second is R2, third is R3. And what do you think? Current which flows in this main circuit, which is represented by I, do you think the same flows through each of the resistor? Yes. For the flow of current, there is only one path. If current I flows through R1, I mean to say first resistor, then the same current passes through R2 also. The same current passes through R3 also, because there is only one path for the flow of current. That's why in this combination we can conclude that in this combination I, that means current, remains same. The same current flows through each of the resistor. This is first characteristic of series combination of resistor. Now if we measure potential difference between positive and negative terminal of this battery, and if it is 12 volt, or let's say this is the total potential difference which is denoted by V, and it is if 12 volt, and if we measure PD across first resistor, second resistor and third resistor, what is found? the sum of the PD across each resistor is found to be equal with the total potential difference between positive and negative terminal of this battery. But do you remember what is potential difference? What is it? Potential difference means the energy conversion between 2 points of the circuit by the flow of 1 unit charge. It was taught in previous class. PD means the work done between 2 points of the circuit by the flow of 1 unit charge, or the energy conversion between 2 points of the circuit by the flow of 1 unit charge. It means when 1 unit charge flows from this point to this point, what amount of work is done between these 2 points, or what amount of electrical energy converts to heat energy in between these 2 points is taken as potential difference across this first resistor. It can be denoted by V1. And in the same way, PD across second resistor can be denoted by V2, and PD across third resistor can be denoted by V3. And according to the experiment, if this total potential difference V is 12 volt, what is found? The sum of the PD across each resistor is also 12 volt, maybe 4 volt, 4 volt, 4 volt, or 6 volt, 4 volt, 2 volt. But the sum of the PD across each resistor is found to be equal with total potential difference. That's why I can write this second characteristic, V is equal to V1 plus V2 plus V3. And in sentence, what can we say? Total potential difference in this type of combination of resistor, total potential difference is equal to sum of the potential difference across each resistor. This is second characteristic. Now, do you remember Ohm's law? Ohm's law was taught in previous class. And according to Ohm's law, V equal to IR. We know this. If it is so, then for this first resistor, not V, here it is V1. V1 equal to what? V1 is equal to, current is same I, but resistance of first resistor is R1. That's why V1 equal to IR1. For second resistor, V2, PD across second resistor, that is V2 equal to IR2. And for third, V3 equal to IR3. I want to substitute this value in this equation. If values are substituted, in place of V, I can write IR. In place of V1, IR1. In place of V2, IR2. And V3, IR3. Now, if we take I as common, then we will have R1 plus R2 plus R3. If there are other resistors, then that also comes after plus R4, R5, etc. Now, I is cancelled. Therefore, our conclusion is R is equal to R1 plus R2 plus R3. This is third characteristic. What it means? It means when resistors are connected in series, then total resistance of the circuit is equal to sum of the resistance of each resistor. Total resistance R is equal to sum of the resistance of each resistor. R is equal to R1 plus R2 plus R3 and so on. These are the characteristics of series combination of resistor. If you are told to write the characteristic, or if you are told to say the characteristic of series combination of resistor, then you can say these points. Look at this characteristic of series combination of resistor. Same current flows through each of the resistor. 1 point, one characteristic. If 1 ampere current is flowing in main circuit, I mean to say main wire, this, the same 1 ampere flows through this also, this also, this. If 2 ampere is flowing, then each of the resistor get the same 2 ampere current. Now, second point, total potential difference is equal to, total potential difference is denoted by V, is equal to sum of the potential difference of each resistor. Mathematically, we can write V equal to V1 plus V2 plus V3 and so on. Now, third point, total resistance is found to be equal to the sum of the resistance of each resistor. Total resistance is denoted by R. R is found to be equal to R1 plus R2 plus R3. In series combination, we are talking not about the parallel combination, we are talking about the series combination when resistors are connected in series. Do you know where do we connect this resistor in series? In the decorating light. Decorating light which we use in festival, maybe in Dasai, Tihar or any other festival, the decorating lights are connected to each other in series combination. This is the example of series combination. Okay, now what are the advantages of series combination? These are characteristic. Now I am talking about the advantages. What advantage we get if resistors are connected to series, connected in series combination? Look at this. Number one, the circuit does not overheat easily. Circuit doesn't overheat easily means according to Ohm's law, V equal to IR. If we take this R in left hand side, V by R equal to I. If we connect more and more resistor, then resistance, total resistance increases, and when V is divided by total resistance, then value of current decreases. That's why the current in the circuit won't be so high and overheating of the circuit is not possible, and this type of connection can be made in those places where inflammable materials are stored. Okay, next. The defect in the circuit can be easily identified and corrected due to the simple construction of the circuit. This is very simple construction of the circuit, and defect can be identified, corrected very easily. This is very simple point. Now next, output voltage can be increased easily. If we use more number of battery, then voltage will increase. If we supply more voltage from some source, then the voltage, each of them get high voltage. That means output voltage can be increased easily. Now next, each resistor gets equal current. Look at this, they are connected in series. There is only one path for the flow of current, and that's why if 1 ampere current is supplied, then the same 1 ampere current flows through each of them. 2 ampere if supplied, the same current flows through each of them. Now this is all about series combination of resistor for today. Now I want to go through parallel combination of resistor, what it is. Look at this, we can define this way. When one end of each resistor is connected to a common point and another end of each of them is connected to another common point, and the common points are connected to a source of electricity, then the combination is called parallel combination of resistor. Looking at this long sentence, long definition, we cannot understand so clearly. That's why I want to show you animated diagram. Look at this. This is a resistor. Another resistor is kept just in front of it, and third resistor is also kept in front of it. Now I am going to join them in parallel. How? If one end of each of them, this end, and this end, one end of each of them is connected to a common point. Look at this. This is the common point. And another end of each of them, if they are connected to a common point, now we have two common points. And if these two common points are connected to a source, maybe a battery, then current flows from positive to negative terminal. This is the diagram which represents the parallel combination of resistor. Now I am going to make this diagram on the board, and I will tell you the characteristic of this type of combination. I mean to say, if we connect resistors like this or appliances of our house like this, actually in our house the appliances are connected in this way. I mean to say, each of the appliance is connected to each other in parallel, and that's why the voltage supplied by the source, that is 220 volt, each of them gets same 220 volt because of the parallel combination. I want to describe this with the help of another diagram. Look at this. This is battery and it is connected to resistors. This is parallel combination of resistor and current flows from positive terminal to negative terminal this way. This is conventional current. Okay. Now let's say this is 12 volt battery, and if we neglect the internal resistance, we can expect that the potential difference supplied to this circuit is 12 volt. I mean to say PD between positive and negative terminal of this battery is 12 volt. This is total potential difference in the circuit. Now resistance of each of the resistor is different according to their length, according to their thickness, according to the material. Resistance will be different. And if we measure potential difference across first resistor, then it is found the same 12 volt. And if we measure potential difference across second resistor, then it is again found the same 12 volt, and PD across third is also found 12 volt. It means first conclusion, first characteristic, what can we say? Voltage or potential difference across each of the resistor remains same. Potential difference across each of the resistor remains same, because we can measure this and we can get the result, the same result. I mean to say 12 volt, 12 volt, 12 volt. Each of the resistor is supplied with the same potential difference. I mean to say same voltage. But what do you think? When current comes from this side and when it enters from this point, there are three paths for the flow of current. Then I divides among these three paths, and it will be I1 here, it will be I2 here, and I3 here. It will be different in different path, because from this point current divides among three resistors. That's why the value of current doesn't remain the same I. If 1 ampere current is supplied, then the same 1 ampere divides among these three. Sometimes maybe equally divide, sometimes maybe unequally divide. It depends upon the resistance of the resistor. Okay. Now second point, what I told you just now, in this combination total current is equal to sum of the current flowing through each resistor, I equal to I1 plus I2 plus I3 and so on. Now according to Ohm's law, we know V equal to IR. If it is so, then I equal to V by R. And for first branch, this V remains same, 12 volt. V equal to current is I1, resistance is R1. That's why for first branch V equal to I1 R1. And so I1 is equal to V by R1. Now in second branch potential difference is same, V is same. That's why V is equal to current is I2, resistance is R2. That's why V equal to I2 R2. That's why I2 is equal to V by R2. And for third branch potential difference is same, previously measured, and V equal to current is I3, resistance is R3. That's why V equal to I3 R3, and so I3 is equal to V by R3. Now I want to substitute this value in this equation. In place of I can write V by R. In place of I1, I can write V by R1, and here V by R2, here V by R3, and so on. Now if we take V as common, then what we get? 1 by R1 plus 1 by R2 plus 1 by R3 and so on. What it mean? V cancel. Therefore R, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. This is third characteristic. I told about potential difference. What will be the effect of this combination on potential difference? It remains same. What will be the effect of this combination on the current? Total current is equal to sum of the current flowing through each of the resistor. Now, third conclusion is not total resistance. 1 by R means reciprocal of the total resistance. Reciprocal of the total resistance is equal to sum of the reciprocal of the individual resistance. It means 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. This characteristic can be represented this way in sentence. Characteristic of parallel combination of resistor. Each of the resistor gets same voltage. Voltage is same. If 12 volts supplied, each of them gets same 12 volt. In household circuit, 220 volts supplied and each of the appliance gets same 220 volt, means per coulomb charge 220 joule energy is supplied, and all the appliances are designed in such a way that they run with 220 joule per coulomb charge. Okay, second point. Total current is equal to sum of the current flowing through each resistor. Mathematically, I equal to I1 plus I2 plus I3 plus ... And third point, reciprocal of the total resistance is equal to the sum of the reciprocal of the individual resistance. Mathematically, 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. These are the characteristics of parallel combination of resistor. When resistors are connected in parallel, it happens. I mean to say, effect on voltage, effect on current and effect on resistance. Now, I want to talk about the advantage of this type of combination of resistor. What are the advantages? Look at this. Number one, we can say each appliance gets full supplied voltage. If we are supplying 220 volt, each of the appliance gets the same 220 volt. If 12 volt, each of the appliance gets same 12 volt. And individual switch can be used with each appliance to use them separately. This is one of the great advantages. What? Look at this. We can take a switch here. If switch is used and this is off, and here another switch which is on. Another switch here if this is on. Then what happens? Current flows through this second path and third path, but first path is empty. I mean to say, current doesn't flow through this path. According to the requirement, if we want to light a bulb kept in the second branch, then we can switch on the circuit and second branch gives us light. And if a bulb is used here in third branch and it is lighted, then it will give us light. But first branch, if bulb is used and we don't want to use it, then switch can be made off. This way, according to requirements, sometimes 1, sometimes 2, sometimes 3, or sometimes all can be switched off. Individual switch can be used with each of the appliance to use them separately. Separately, we can use them. Next, each appliance gets required amount of current according to their resistance. According to the resistance, they pull the required amount of current. Current is different in this circuit, and according to their resistance, the value of current varies. Okay, now next, an appliance can be replaced or new appliance can be added easily without affecting the other appliance. If we want to replace this is a resistor. If you want to replace it with a bulb, then you can replace it with the bulb. There is no effect on other brands. That's why the appliance can be replaced or new appliance can be added easily. If you want to add another appliance, then you can add another appliance without affecting the other circuit. These are the major advantages of the parallel combination of resistor. Now I think I finished the combination of resistor, series and parallel. Now this is break. I want to take a break with the question. Let's have a question. Statement. In the parallel combination of resistor, one end of each resistor is connected to a common point and another end of each of them is connected to another common point. Is it correct? This statement is correct or not? Just think about this. And another one, argument 1. In this combination, total potential difference is equal to sum of the potential difference of each resistor. Do you think this argument is correct or incorrect? Just think about this. And argument 2, in this combination, same current flows through each resistor. After seeing all these statement and arguments, we have to select one of the option among these. Statement and argument 1 are correct, statement and argument 2 are correct, argument 1 and 2 are correct, only statement is correct. Now which one is correct? We have to select one of the option. Okay, statement and argument 1 are correct. Let's see it. In the parallel combination of resistor, one end of each resistor is connected to a common point and another end of each of them is connected to another common point. This is correct. The statement is correct. Argument 1 is also correct. Let's see argument 1. In this combination, total potential difference is equal to sum of the potential difference of each resistor. What do you think? No, this is incorrect. This is correct for series combination, not for parallel combination. That's why half of the part is correct, half of the part is wrong, incorrect. So we'll drop this option number 1. It's incorrect. Option number 2, statement and argument 2 are correct. Statement is correct, previously decided. Now argument 2, in this combination, same current flows through each resistor. Is this correct? No. The same current doesn't flow through each resistor because this is correct for series combination only. That's why this second option is also incorrect. So we'll drop this. Number 3, argument 1 and 2 are correct. Argument 1 and 2 are incorrect, previously decided. That's why this option is also not correct. I'll drop down this. Okay. Now only statement is correct. Yes, statement was correct from the beginning. That's why number 4, option number 4 is correct. We'll tick on it. Okay, after the question, now we have to go through numerical problem also. Look at this numerical problem. What will be the total resistance when two resistors are of resistance 10 ohm and 20 ohm are connected in series and in parallel? Draw a diagram for each case. We have to draw a diagram also. We have to calculate also total resistance. Now let's go through the solution. Now I'm going to connect this first in series and second in parallel. Okay, this is series connection. When resistor, there are two resistors, one having 10 ohm resistance. Let's say this is R1, its resistance is 10 ohm, and this is R2, its resistance is 20 ohm. Now there is parallel connection also. We have to show. In parallel connection, the same. This is first resistor. This is second resistor. We are connecting them in parallel this way. This is R1, this is R2, and R1 is 10 ohm and R2 is 20 ohm. Okay. Now we have to calculate the total resistance. In this case, total resistance R is equal to R1 plus R2. This is equal to 10 ohm plus 20 ohm, and this is equal to 30 ohm. Here total resistance is equal to, the reciprocal of the total resistance is equal to sum of the reciprocal of each resistance, and that's why 1 by R is equal to 1 by 10 plus 1 by 20, and in right hand side, if 20 is taken as LCM, then 10 2s are 20 plus 1, or 1 by R is equal to 3 by 20, and therefore R is equal to 20 by 3. If we divide 20 by 3, 3 6s are 18, 6 is 18, 0.36 is 18, again 666 comes, that's why I want to write 7, and total resistance is 6.67. Look at this, when resistors are connected in series, total resistance increases, but when resistors are connected in parallel, then total resistance decreases. Now look at this numerical problem also. Here resistors are connected in different way. Now how can we solve this? If we take them as R1, R2, R3, R4, then this we can calculate this way. R1 and R2 are in parallel. R1 and R2 are in parallel, that's why 1 by R dash is equal to 1 by R1 plus 1 by R2. And this is equal to 1 by R dash is equal to 1 by R1, R2, both are 4 ohm, that's why 4 plus 1 by 4, or 1 by R dash is equal to 4 is taken as LCM 1 plus 1, or 1 by R dash is equal to 2 by 4, 2 1s are 2, 2 2s are 4, therefore R dash is equal to 2. Now this is the total of this R1 and R2. In the similar way, if we take the total resistance of R3 and R4, then we will get the same result. That's why again 1 by R double dash is equal to 1 by R3 plus 1 by R4, and this is equal to 1 by 4 plus 1 by 4, and this is equal to here it was previously calculated, that's why therefore R double dash is equal to 2. Here 2 ohm, here 2 ohm. Now total resistance, therefore total resistance R equal to R dash plus R double dash, and this is equal to 2 ohm plus 2 ohm, and therefore R is equal to 4 ohm. This way we can calculate. Okay, look at this another. How do we solve this? This 6 ohm, 6 ohm, everywhere 6 ohm. These two are in series, but these two are in series, but this is parallel with these two. That's why if we write R1, R2, R3 and R4 and R5, R1 and R2 are in series, we can get total of these two, and this series combination is in parallel with R3. We can do this way. Here R dash is equal to R1 plus R2, and this is equal to R1 and R2 both are 6 ohm plus 6 ohm, this is equal to 12 ohm, and this R dash is in parallel with this R3. So we can say that 1 by R double dash is equal to R dash 1 by R dash plus 1 by what? R3. This will give us this R double dash. Now I don't want to solve each and every with the number. Now this R double dash, which is the total of this R1, R2 and R3, this is R double dash. It is in series with R4 and R5. That's why total resistance R is equal to R4 plus R double dash plus R5. This way you can calculate, you can get the total resistance, and the answer comes 16 ohm. Okay, now look at this last one. Here also this R1, R2, R3, these three are in series, and that's why we can get R dash is equal to R1 plus R2 plus R3. We are getting R dash first, and this R1 plus R2 plus R3 gives R dash, and this is parallel with this R4. So we can get 1 by R double dash is equal to 1 by R dash plus 1 by R4. Now we will get R double dash. and R double dash is the total of R1, R2, R3 and R4. Now it is in series with R5 and R6. That's why total resistance R is equal to R4, R5 and R6, R5 plus R double dash plus R6. Now we'll get the total resistance, and this total resistance will be 8.25 ohm. Now I think this is the end of the class, because I taught a lot of matter today, especially series combination and parallel combination of resistor, its characteristic and some numerical problem related to it. Now we'll meet in another class in the same electricity. This much for today. Thank you.